We move on to the addition law of probability. Oh, Katie asked when our test was going to be. I know it's not this week. It might be the end of next week, but it will probably push a little bit further after that. But it won't be before Friday of next week. I know that. Okay? Okay. It will not be before Friday of next week.
So we have like a while.
Yes, because probability is a large unit.
Okay.
Today we move on to the addition law of probability. And this formula is in our reference sheet. It says for two events, A and B, then the probability of A union B, which can be thought of as you saying or, the union can be thought of you saying the word or, it says probability of A or B, is equal to the probability of A plus the probability of B minus the probability of A intersect B, and the intersect can be thought of the and. And we kind of already hit on this when we were using our two-way tables. And I keep pointing at them, but Harrison mentioned the overlap. Well, when systems can overlap, and you say the probability of or happening, if you're not careful, you could double count stuff. So what this formula is telling you to do, it says, if you want to know the probability of A or B, you add up the probability of A and the probability of B, you add them together, and then you subtract the overlap. And that's because if you don't subtract the overlap, they get double counted. Make sense? So that's what the formula says. It's very easy to do. So for the first example, it's not even a word problem. It's just probabilities of things and numbers. I'll go ahead and tell you that there are questions like this on your test, but they're not as easy as what you're about to see me do. They make you think, okay? Probability of A is 0.6. The probability of the union is 0.7. The probability of the intersection is 0.3. So find the probability of B. Okay, well, I'm going to write the formula. The probability of A union B is equal to the probability of A plus the probability of B minus the probability of the intersection. And we just fill in the numbers that we know. 0.7 equals 0.6 plus this unknown probability minus 0.3. And then you just solve for the probability of B. Well, 0.6 minus 0.3 is 0.3. And if you subtract 0.3 from both sides, you find out that the probability of B is 0.4. There, done. Now we've already kind of hit on this topic before, again, when we were doing our sets and Venn diagrams notes. But when you have a system where A and B do not overlap, we say that those are disjoint or mutually exclusive. But now that we have a definition of the addition law of probability, we can use this knowledge in another light and go, okay, well, what does that mean as far as the equation is concerned? Well, think about it. If they don't overlap, then the probability of the intersection is 0, right? So this addition law of probability works even when you have disjoint sets because the probability of the intersection equals 0. So what you find is that the probability of A or B, meaning A union B, what you find is that it's just strictly equal to the probability of A plus the probability of B because it's impossible that A and B happened at the same time. Yeah. So the law is always true, even when the overlap can't exist. That's all that says. Here we got a box of chocolates. Life is like a box of chocolates. A chocolate is randomly selected from a box which contains 6 chocolates with hard centers and 12 chocolates with soft centers. Let H be the event that a randomly selected chocolate has a hard center, and S be the event that a randomly selected chocolate has a soft center. Now, part A asks, are events H and S mutually exclusive? Is it possible for you to pull a chocolate out of this box that has a hard center and a soft center? No. Because that is impossible, they are mutually exclusive. No chocolates have a hard center and a soft center at the same time. So you just say yes.
I think this
Oh, God, no, it's not this easy on the test. You kidding me? Absolutely not. Alrighty, we're just going to find these probabilities. What is the probability that we select a chocolate with a hard center? Well, how many chocolates with hard centers are there? 6. And how many total chocolates are there? 18. We can reduce this to 1/3 if we want to. Remember, sometimes you don't want to reduce because you're going to be asked questions that require you to add and subtract fractions, which means you kind of want a common denominator. What is the probability of a soft center chocolate? Well, it would be the rest of the chocolates, wouldn't it? It should be 12 out of 18, which is 2/3. They are mutually exclusive. So what is the probability of H intersect S? 0. The intersect does not exist. Well, if the intersection does not exist, then what is the probability of H union S? 1. There you go. Easy, right? Again, probability is not difficult because its individual pieces are difficult. Probability is difficult because when you put it all together, there's a lot going on. There's a reason why statisticians get paid so much. There is serious money in probability and statistics. Big, big money.
Why is it 1?
Because it's absolutely guaranteed to happen.
Oh, that's either going to be soft or hard.
Right.
Okay.
Yeah, you pull a chocolate out of this box, guaranteed it's either a hard center chocolate or a soft center chocolate. It's one of them. And then the end of our short notes. Same kind of question. A class of 30 students was given a history test. 7 students scored an A and 11 students scored a B. A student is randomly selected. It says let A be the event that a student gets an A and B be the event that a student gets a B. Are A and B mutually exclusive? Yes, of course they are. There's no way a student is getting an A and a B on the exact same test, unless, of course, they're using an IB curve like mine, but no, that's not what they're asking. So, again, we just say yes, right? Now it's the exact same question, just with a different scenario. There is absolutely nothing different here. What is the probability that a student gets an A? 7 out of 30. Not overthinking this. What is the probability someone gets a B? 11 out of 30. What's the probability somebody gets an A and a B? 0. And what is the probability that someone gets an A or a B? 18 out of 30? That is it. Because we only know about 7 and 11. So there's another 12 people that we don't know anything about. They got neither an A nor a B. So we get 18 out of 30 because we're adding the 7 and the 11 out of 30. You can reduce this if you like to, but you don't have to.
Okay.
I wouldn't. Yes?
So I cannot get them straight. So the N means and.
It's a
And
Just A, because there's that
for and then the other one's just
but U means union, put them together.
okay.
But it's not an in. It's a upside down U.
I know.
Okay. But that's it. That's it for the notes for today.